From the 7 chapter integrals, exercise 7.2, we have completed 20 questions. So now we will find the integral of the 21st question. So integral of tan square of 2x minus 3 with respect to x. So we have to find the integral of the trigonometric function, that is tan square. So is there any direct formula, integral of tan square? But we have integral of tan x, right, which is log of secant x modulus of secant x plus c. So we don't have direct formula. So we need to take the help of some other trigonometric function that is linked with tan square. So we have an identity, right? 1 plus tan square x is equal to secant square x. So why we are selecting this identity? To change trigonometric function tan square to secant square, because there is a direct formula for secant square x. So integral of secant square x is tan x plus c. So this implies integral of secant square 2x minus 3 minus 1 with respect to x. So by applying this formula, now this implies, this can be written as secant square 2x minus 3 with respect to x minus integral of 1 dx. So now we changed from tan square to secant square, right? So now we will do the substitution method. So let 2x minus 3 is equal to t. So now we will differentiate with respect to x. So we will get 2 is equal to dt by dx. So dx will be equal to dt divided by 2. So now this implies integral of secant square t dt by 2 minus integral of dx. So now this implies 1 by 2 integral of secant square t dt minus integral of dx. So this is 1 by 2 tan t minus x plus c. So now let us substitute for t. So this implies 1 by 2 into tan of, so in the place of t we will write 2x minus 3 minus x plus c. So this is the integral. So therefore integral of tan square 2x minus 3 dx is equal to 1 by 2 tan of 2x minus 3 minus x plus. Let us find the integral of secant square 7 minus 4x with respect to x. So this is quite simple because we know the formula, right? Integral of secant square x is dx. So no need to change the original secant square function. Now by substitution method, let 7 minus 4x is equal to t. Differentiate with respect to x. So we will get minus 4 is equal to dt by dx. Now dx will be equal to minus dt by 4. So let us substitute secant square. So in the place of 7 minus 4x we will write t, and in the place of dx we will write minus dt by 4. Now this implies, so minus 1 by 4 is constant, so we will write outside, and this is secant square t dt. Now this implies minus 1 by 4, integral of secant square t is tan t plus constant of integration. So now this implies minus 1 by 4, so in the place of t 7 minus 4x plus c. So therefore integral of secant square 7 minus 4x dx is equal to minus 1 by 4 tan of 7 minus 4x plus c. So this is the required integral. Now 23rd one, we have to find the integral of sine inverse of x divided by square root of 1 minus x square with respect to x, right? Now this can also be written as integral of sine inverse x into 1 divided by square root of 1 minus x square with respect to x. So if we multiply them, we will get back the previous step. Okay. Now they have given inverse trigonometric function, sine inverse function, and we know the formula. If we differentiate sine inverse x, we get 1 divided by square root of 1 minus x square. So both sine inverse x and 1 by square root of 1 minus x square, the integrand. So when we have such type of situation, we will apply the substitution method, right? Both function and its derivative. Now which one to equate as t? Whether sine inverse x or 1 by square root of 1 minus x square, it's the original function. So we have to take this original function and equate it to t. So let sine inverse x equal to t. So now we will differentiate with respect to x. So this is 1 by square root of 1 minus x square is equal to dt by dx. But we have to do the substitution for this entire thing, 1 by square root of 1 minus x square dx. So for that we will cross multiply. 1 minus x square dx is equal to dt. So now this implies integral of, in the place of sine inverse x we will write t, and here we will write dt. Now this implies, so we know the formula, right? Integral of x power n dx, specifically when n is not equal to minus 1, then this will be x to the power n plus 1 divided by n plus 1 plus c. So here the value of n is 1, it's not minus 1, right? So therefore we can apply this formula. So this will be t square by 2 plus c. So this implies, in the place of t we have to write sine inverse x the whole square divided by 2 plus c. Therefore integral of sine inverse x divided by square root of 1 minus x square dx is equal to sine inverse of x the whole square, we'll write 1 by 2 here, plus constant of integration. So this is the required integral. So now we can take down 3 important formulas. So integral of secant square x dx will be tan x plus c. Now integral of secant square, now linear function, ax plus b dx is equal to, so we have to write 1 divided by the coefficient, right? 1 by a into tan of ax plus b plus c. Now integral of secant square b minus ax. Now the coefficient of x is negative, minus, right? dx is equal to, so what we have to write here, minus 1 by a to tan of b minus ax plus c.